Methyllithium behaves differently from typical covalent molecules because the bond between carbon and lithium is extremely polarized, giving the carbon much more negative character and making the pair act more like an organometallic ion than a neutral covalent compound. Think of a normal covalent bond like two kids sharing a seesaw evenly. But here, lithium is so much less able to hold onto the shared electrons that the carbon ends up sitting way down on its side. That means the carbon in methyllithium is unusually rich in electrons and can act like a strong base and a very reactive nucleophile, attacking positive centers or acidic hydrogen atoms. In solution, methyllithium often exists as aggregates or in contact pairs with lithium, coordinating to solvent or other molecules, which affects how reactive and how soluble it is. Because the bond has a lot of ionic character, chemists often treat the carbon as if it were a carbon muon, a negatively charged carbon center, even though a perfect ionic separation is not always present. Students often assume methyllithium behaves just like a neutral alkane methyl group, and forget it is highly reactive toward air and water. The simple fix is to always handle it under dry, inert conditions, and respect that it will deprotonate even weak acids. Another common mistake is ignoring aggregation and solvent effects when predicting reactivity. Checking the solvent and concentration can change whether reactions are fast or slow. Some people think the bond is purely ionic and expect free lithium ions and methyl anions floating separately. But the reality is intermediate bonding and coordination, so thinking in terms of polar covalent with ionic tendencies, gives better predictions. For more videos and resources on this topic, visit www.gumballdegree.com.